Hello everyone, my name is Mohit Solanki and I welcome you all to this session. Today we are going to explore a very important topic in operating system, process scheduling. Whether you are a student preparing for exams or someone trying to understand how operating system manage multitasking, this topic is a must. In this video, we will break down the types of process schedulers, understand how they work, and see how they impact overall system performance. So, stay tuned and let's dive into the world of process management together. In any multitasking operating system, multiple programs or process compete for the CPU. But who decides which process gets the CPU and when? That's where process scheduling comes in. In It's a manager inside your computer that makes sure all the process gets fair and efficient CPU time without causing delays. In this session, we will learn how operating systems use three types of schedulers: long-term, mid-term, and short-term, each handling different levels of process management. We will also explore the types of scheduling techniques, including first come, first serve, shortest job first, priority, and round robin, and see how they impact speed, fairness, and system performance. By the end, you will understand how smart scheduling keeps your computer responsive, efficient, and fair to all running tasks. Introduction to process scheduling. Process scheduling is a fundamental concept in operating system, acting as the backbone for efficient resource management. It involves organizing and managing the execution for various processes to maximize system resource utilization. The ultimate goal is to meet the critical system objectives such as fairness amongst the process, high throughput, and optimal response time. Optimal response time. Modern operating systems, including widely used platforms like Windows, macOS, and Linux heavy, rely on sophisticated process scheduling mechanisms. This system ensures that all running applications and background tasks are handled smoothly, providing a response and stable user experience. Effective scheduling is a crucial for multitasking environments, preventing bottlenecks and ensuring that no single process monopolizes system resources. So now we are on the next slide, which is process state diagram. Now we will see in a very short way that what these three types of schedulers do. Long-term scheduler, short-term schedulers, and medium-term schedulers. Long-term schedulers select the process which are admitted into ready queue, controlling the degree of multi-programming. Long-term schedulers puts the jobs from new state to ready state. Short-term CPU schedulers pick one of the ready processes to execute on the CPU. So when the process comes in the ready state, the short-term schedulers shift it into the shift it into execution. Medium-term schedulers temporarily removes the process from memory swapping to reduce memory load and improve performance. Process schedulers overview. Core OS component. Process scheduler is an integral part of the operating system kernel, acting as the brain behind the process execution. It is responsible for deciding which process gets the access to the CPU and for how long, ensuring smooth multitasking. It is primary ready queue management. Its primary focus involves the selecting the next process to execute from a pool of ready processes often stored in a ready queue. This selection is based on various parameters and chosen scheduling algorithms. Balancing act. The scheduler constantly balances critical system objectives, maximizing CPU utilization, minimizing response time for interactive applications, and ensuring fairness among all these competing processes. This complex balancing act is vital for overall system performance. Algorithm driven. Its operations are entirely dedicated by specific schedule algorithms and policies. These algorithms define the rule by which processes are prioritized and allocated CPU time, directly influencing the system efficiency and user experience. Classification of process schedulers. Process schedulers are broadly categorized into three distinct types: long-term, medium-term, and short-term scheduler. Each type operates at different level within the operating system hierarchy, contributing to the overall process management. They are designed to optimize specific aspects of system performance, from controlling the number of processes in memory to rapidly allocating CPU time. These schedulers do not operate in isolation but work cooperatively to ensure that the processes are managed efficiently through their life cycle. Their coordinated efforts are crucial for maintaining system stability, responsiveness, and resource utilization, adapting to various workload demands and placed on the operating system. Now we are going. Now we will see long-term schedulers, which is also called job scheduler. Long-term schedulers also handles the degree of multiprogramming. It is also known as job scheduler, controls the degree of multiprogramming, select processes that are ready for execution. Job pool selection. Selection processes from job pool on the disk. Selects processes from job pool on the disk. Determine CPU time competition, control system access. Batch system importance. Handles jobs submitted in groups, operates without direct user interaction, ensures continuous job flow, which means when jobs are when jobs come in batches, it handles the jobs in groups, operates without direct user interaction, and ensures the continuous job flow. It also maintains the m- mix of IO bound and CPU bound processes, maximize system utilization. It also prevents resource bottleneck. Medium-term scheduler or mid-term scheduler, which is also called swapper. It reduces the mm, multi-programming. The medium-term scheduler's core function is to reduce the degree of multi-programming by temporarily removing processes from main memory. So the mid-term scheduler does that when a very big task is running in the memory. So when another task comes, the medium-term scheduler removes it from the uh, disk for a few times and let the second processes be conducted, and then it again sh after when the other job is finished, then it again swaps it into the memory. Swaps out. It swaps out processes to disk elevate consumption in memory or when a process becomes inactive, making room for other active processes. Swapping. Conversely, it swaps in processes from disk back into memory, typically to resume execution or to improve the overall mix of ready processes. Optimize process. This dynamic swapping improves memory use by optimizing the process mix, making better use of space, and boosting performance, especially in time sharing systems. The medium term scheduler handle processes that are blocked on IO operation or waiting for other resources, temporarily moving them out of active memory until they are ready to proceed. Its execution frequency is more often than the long-term scheduler, but less frequent than the short-term scheduler, making decisions that impact memory utilization and system responsiveness. So it helps in making the decision that impacts memory utilization and system responsiveness. So it plays a very important part. Now we are moving towards short-term scheduler, which is also called CPU scheduler. Immediate CPU allocation. The short-term scheduler is responsible for making instantaneous decisions about which process should gain access to the CPU next. It's the most frequently invoked scheduler. High frequency, invoked every few milliseconds. Works to this scheduler works to minimize CPU idle time, ensuring the processor is almost always busy executing process. So it should not remain free. It ensures the processor is almost always busy executing a process. Performance optimization. Its primary goal is to optimize CPU utilization, maximum system throughput, number of processes complete, and achieve quick response time for interactive users. It directly impacts system responsiveness and efficiency. Algorithm dependent. It utilizes a variety of complex scheduling algorithms such as first come first serve (FCFS), shortest job first, and priority scheduling to determine the next process to run based on the specific criteria. This scheduler operates at the lowest level and directly controls the flow of execution on the CPU. Its rapid decision is critical for multitasking and ensuring a smooth experience in modern operating systems. So now I am going to explain the topic preemptive and non-preemptive. So now we are going to discuss preemptive scheduling. In preemptive scheduling, the OS can interrupt a running process. Like a process is gone into the operating system. So we were discussing preemptive scheduling. In preemptive scheduling, the OS can interrupt a running process. Let's suppose a process is running in the OS and a process is running in the CPU. Sorry, in preemptive scheduling, the OS can interrupt a running process. This happens if a higher priority process becomes ready or the time slice expires, which was given to the process. It improves fairness and response time. No single process can hold the CPU for too long. Now I am going to explain non-preemptive scheduling. In non-preemptive scheduling, a running process keeps the CPU until it finishes or makes an IO request. The OS cannot stop it before that. This method is simple but can cause delays. Let's suppose a long process may block the shorter ones, leading to poor responsiveness. It is mostly used in batch systems, not in modern interactive systems. Now, we will take a quick look on common scheduling algorithms. FCFS, first come first serve. First come first serve runs process in arrival order. It's simple but can cause long waits for short tasks if a long one comes first, leading to the poor performance. If a very long task came, then the short task will have to wait for a very long time, which can reduce the performance. Now we will talk about SJF, shortest job. But shortest job first minimizes average waiting time by running the shortest task first. It's optimal but impractical as it needs knowledge for future execution times. Priority scheduling. Priority scheduling runs the processes based on priority levels. It's efficient but may cause starvation if low priority tasks are constantly delayed by high priority ones. Round robin. Round robin CPU scheduling gives each process a fixed time slice in turns. It ensures fairness but can cause overhead from frequent context switchings. Other notable algorithms include multi-level queue scheduling, which divides the ready queue into several separate queues, and earliest deadline first, commonly used in real-time system to meet strict deadlines. Now, I am going to explain you these types of scheduler using a very simple example. Let's suppose I am playing a game on my laptop. So when I when I will start a game, let's suppose I am playing GTA 5. So what will a long-term scheduler do? So it will launch is the user will launch GTA 5. The OS checks the system loads. GTA 5 is admitted into the memory while heavy startup apps are postponed. Now, what will short-term scheduler do? So the games start executing. CPU scheduler assigns GTA 5 a processing time select to execute. It will give a time slot to execute. Its role, it manages the execution of ready processes. Medium-term scheduler. What will a medium-term scheduler will do? Due to the heavy task, system RAM will get overloaded due to I am running a very heavy task, which is a GTA 5 game. Now, due to this, other activities like Windows updates and all of these were postponed. But when I pause the game, background processes like Windows update are swapped out. GTA 5 background processes like Windows update are swapped out. GTA 5 continues to run smoothly. When a game is paused, updater is swapped back in. So again, I'm going to explain you. Uh, I have launched the game. It OS checks the system load. If it can run the game, it will start running the game. So when the game is running, as it is heavy, the other apps which were present will stop running. Now, what will short-term scheduler do? Short-term scheduler assigns GTA 5 process time slices to execute. Now, what will medium-term scheduler do? Due to the heavy task running of GTA 5, other tasks were paused to execute. When I will switch off the game or pause the game will be swapped into the disk. So the swapping is done by the medium term scheduler. And when the game is swapped into the disk, now again the Windows update and all other apps which were running before now came in the RAM again. So this is how long-term scheduler, short-term scheduler, and medium-term scheduler works. Summary and conclusion. Critical. It is critical for OS efficiency. Process scheduling is a paramount for the efficient operation of any modern operating system, enabling effective multitasking and resource management. Layered management, different types of schedulers, long-term schedulers, medium-term schedulers, and short-term schedulers collaborate to manage process across various levels from admitting a new job to allocating CPU time. Algorithm impacts. The selection of a specific scheduling algorithm significantly influences overall system performance, affecting metrics like throughput, response times, and fairness. Balancing acts. A balancing act. Achieving optimal system operation requires a careful balance between conflicting a criteria, scheduling criteria to meet diverse system objects and user demand. Ongoing research in process scheduling continues to focus on developing more adaptive, intelligent, and energy-aware algorithms. This advantage aims to further enhance system performance, user experience, and resource efficiency in increasingly high complex computing environments. Thank you. I hope you have understood the topic.